Hello, I'm Anna Mackay and this video is on series. Just a bit of a refresher of where we've come from. We've done sequences, we've done arithmetic, this is going to be very scribbled here, arithmetic sequences and geometric sequences. So what is the difference between those? How do we tell them apart? So if we had a set of numbers, arithmetic, if we had 11, and we were to say add on 11 each time, plus 11, we'd get 22. So arithmetic is adding something on each time. 33, 44, 55, etc. They have a common difference. And geometric sequences, if we started with the same numbers, if we had 11, but let's say we multiplied through by 2 each time, well, we'd still get 22 there. But now multiplying that by 2, you get 44. Multiply that by 2, 88. Multiply that by 2, 176. And we call that a common ratio. So that's the main difference between arithmetic. It's not arithmetic, it's arithmetic sequences and a geometric sequence. They can have the same initial term, that's fine, of 11 in this case. Notice that the geometric sequences explode much faster, if you like. The numbers get bigger. So arithmetic sequences can be an addition or a subtraction number there for the difference, and geometric sequences can be a multiply or a divide, because technically, remember, multiplying by 2 is the same as if you were to divide by 2, that's also the same as multiplying by a half. So that's an example of how they're interchangeable. Now series are where you take these and add them up. So if you wanted the first 5 terms in that arithmetic sequence, you would be adding them up to get the series. So that's a quick idea of where we're heading with this. An arithmetic series and a geometric series is where you add up a certain amount of terms, or you look at what they're doing forever and ever. Okay, moving on. Some facts here. A series is the sum of the terms of a sequence, as I just said. A finite series ends. Things that are finite have an end. So you might have term 1, adding on term 2, term 3, and you finish somewhere at Tn. An infinite series, as the word infinite suggests, usually goes on forever. They will either do 2 things. It will converge to something. We'll explore that a bit later, or feel free to look that up yourself. Or it's not possible to calculate. Looking at some terminology here, if you have S1, that means the sum of one term. So in that case, it would always be term 1, T1. If you want S2, that's the sum of 2 terms. So term 1 and term 2, and so on. Sn is the sum of the n number of terms, so that's the first term plus the second, all the way up to the nth term. The notation is called summation notation and comes from the letter sigma. That is that symbol there. Practice drawing it a few times. You don't have to get it quite like you would typed up. It comes from the Greek alphabet, and it's the equivalent letter of S in the Greek alphabet. S for sigma, S for sum might be the way of helping you remember that. What does all this mean? When you see this notation here, this is telling the reader it is the sum of all numbers of the form tk, so S for sum of all of the numbers of that form, where k is starts at 1 and is up to n. So in this case, it's all the way up to the nth term. Expand and evaluate these. So we're going to do these by hand, and then I'm going to show you how to do it on your graphics calculator. The first one there, so we have the sum in A here of all numbers of the form k plus 1, where we're starting at k is equal to 1 and we're going up to 7. So let's write them out. Our first one, if k is 1 and we substitute that in there, we have 1 plus 1 gives us 2. So that's our first term. The next term, so we always do whole numbers along, is when k is equal to 2, substitute 2 into here, 2 plus 1 is 3. Next one, k is equal to 3, 3 plus 1 gives us 4. And this 7 here tells us we want 7 terms. So I'm going to count them out as I write them. We've got 1, 2, 3 terms already, 4 terms, 5 terms, 6 terms, 7 terms. Just a point worth noting, it doesn't go up to the number 7, it's 7 terms. Adding them up, you get 35. I think I'm jumping to the calculator instructions now. Yes, here I am. So, in your run mode on Casio, to evaluate that sum, we want to push F4 Math so that you get that on your screen. Hopefully they're the right settings for your calculator. And for the, instead of a K, you're using X, not alpha X. You need to use that button for the X and adding on 1. And you arrow across each time so that you can substitute in the different values here. Noticing that we also put, I've kind of got it in the way here, but you must put the X at the bottom of the summation notation as well, and that will give you 35, which we worked out by hand. And the second one here, it is the sum of all numbers of this form, which is 1 divided by 2 to the power of k, where we're starting at k is equal to 1 and we're going up to 5 terms. So let's practice writing them out. The first one is 1 divided by 2 to the power of 1. The next one is 1 divided by 2 to the power of 2. Next, and so on, to 8, 1 divided by 16, and 1 divided by 32. To give us 31 on 32. So that's the sum of the first 5 numbers in that series. Another example here, considering this sequence. We need to write down an expression for S of n. So what is S of n? That is the sum, S for sum, of the first n numbers in this sequence. So we have to try and recognize the pattern of what's happening here. We have our summation notation, and k, we are starting at the first term, and we're going up how far? We want to go up to the n term, so that sits at the top. We have to be able to identify what's happening to k each time. If k is 1, what do you do to it to turn it into a 1? Have an idea. Apply that rule to the next number. If you had the number of 2, so k is 2, what would you need to do to that 2 to turn it into a 4? Was it the same rule that you had for the 1? Maybe. Hopefully you recognize this set of numbers as the square numbers. So you're taking the value of k and you are squaring it. Same applies for k3, you'd get 9, k4 squared, 16, and so on. So that is our expression for Sn. I suppose we could write Sn next to that. And then part B is find Sn, so for the sum for these different n values. So essentially what we're going to end up doing here is we're going to have 5 sums. For efficiency, you might do this first, lots of equals. So S of 1, it's the sum of one term. What's the first term in this sequence here? Not a sequence. Well, yes, it's a sequence, is 1. S2 is the sum of 2 terms. So we have 1 and 4. That's equal to 5. And so on. So you can see that when we have, feel free to fast forward this, 3 terms here, the next term is 9, and the sum of that is 14. S of 4 is the sum of 4 terms. Gives us a total of 30. S of 5 gives us the sum of the first 5 terms to give us 55. So it's just practice at getting the idea of different sums there. And just the properties here are, I know that some of this can look a little bit confusing. We have the summation notation there that we've talked about, that a property is if you have two terms here split by an addition, you can actually split them and work out the sum of those separately. The rules still apply. And if C is a constant out the front of what you're working with here, you can actually pull it out the front of your sum. And if you're doing the sum of a constant, then because that constant's staying the same each time, you just look at how many times you're adding up that constant and multiply that by your constant. Some basic principles there, addition, multiplication. Okay, if you liked it, give it a thumbs up and subscribe to the channel, and the next video in this series will be called Arithmetic Series. Thank you.